Yeah. Welcome everyone. I welcome you all to the webinar on real-time LLMs. This is a part of the bootcamp, the Spring of LLM bootcamps, which is being organized by Crackpot Data Analytics Group in collaboration with Pathway. It is a free education initiative taken by Pathway, where we'll be
Sorry,
going
just
through
one
the
thing.
integration of Crackpot Data
Uh,
Analytics Group in
Nisarg, sorry.
collaboration with Pathway.
I
It's a free
think
education
the tab is
initiative
open on
taken
your
by
laptop.
Pathway,
There's some echo there.
where we'll be
Sorry,
going
just
through
one
the
thing.
integration
Can you mute that tab? Nisarg, sorry.
collaboration.
Yeah, Nisar, can you unmute in case you're speaking anything? Sorry.
Yeah, sorry for the hiccups. I welcome you all again to the webinar on real-time LLMs on the occasion of National Science Day. So, this is part of a larger bootcamp organized by Kharagpur Data Analytics Group in collaboration with Pathway. Uh, this is a great opportunity for you all to learn how LLMs, which are trained on a preset amount of data, how we can use these LLMs and their knowledge to handle real-time data using different architectures like RAG. So this is going to be introductory session, and we'll go and understand a few fundamentals of real-time LLMs, and we'll also briefly touch upon how this can be used. Uh, so we have Mudit with us, who's a member of Pathway. He'll be guiding you, all of us, through today's session. So I hand it over to him. Yeah, Mudit, you can take it
He'll
now.
be okay, guiding you, yeah. Thanks,
All of us
Nisarg.
through today's session.
Um,
So I hand it over to
One
him.
second. Let me. There is. Yo. Okay. Cool. First
Yeah,
off,
Mudit, you
thanks
can take
everyone.
it.
Let me unmute. Yeah. Let me check if there is no issue at my end. Yep. Looks all good. Sorted. Well, hello. Good morning. Good evening. Good afternoon, depending on which part of the world is joining from. I'm assuming most of you are at IT Kharagpur, and there are some folks who are joining offline as well. So very welcome to IT KGP. Um, Now, I'm Mudit, and this particular session is around using ChatGPT with real-time data. And I've tried to prepare an introductory kind of a presentation so I can walk you through the entire process. It's going to be an educational session, so you'll get some clarity with that. Okay, just allow me to share my screen. One second. Yo. Okay. So first off, like I can't see you, but I can see your comments clearly. Like, so if you have any issues, any doubts, anything whatsoever, you can simply let me know. Like you can comment it and we'll know. And then there's this team of awesome folks at Kharagpur Data Analytics Group who are also there. You can certainly flag if you are facing any kind of issues or something. Okay. So let me start off by sharing my screen. Okay. I'm assuming that this particular audience has a mix of folks who many of you would know what LLMs are inside out. Many of you would have built some production ready applications, and but given my interactions with the colleges that I do on a frequent basis, I've seen that usually we have some understanding, but not in a very crystal clarity understanding of what large language models are, what LLM applications do. Okay, and this particular session is to as is an attempt to kind of share the same. Okay, just a second. Okay, I'm sharing the wrong screen. One second. Yo, let me share the right one. One second. I'm sharing my entire screen. I think that should do the job. Yeah, you can see the screen, right? Yeah, perfect, cool. So we are going to understand how to use ChatGPT with real-time data. When I'm talking about real-time data, it's real-time external data. We'll understand the use cases that we can tackle. This is a collaborative initiative by Pathway, Kharagpur Data Analytics Group, Jim Khan at IT Kharagpur, and of course Kharagpur, the ecosystem who has enabled everything. Now, a quick introduction about me. I mean, this is a very apt introduction of mine. I'm an internally confused AI and growth enthusiast who knows the basics. And there was supposed to be a logo of an academy here, which is kind of missing. But I'm currently with Pathway. It's a French research company. Small group of 23 people, where except three folks, which includes me, everybody's a PhD. Has worked at cool labs like Google, Brain, Meta, Mila AI. Some of them have developed some very foundational models which are extremely popular now. Some very cornerstone architectures and developments in the field. Before Pathway, I was with the AI Planet. It's a community I created as a founding member. It's a 300K AI plus community. And before that, this is an academy, and this is CodeChef. I used to lead business for CodeChef at some point in time, which is a competitive programming platform. So have been dabbling with the tech communities for a while, and that's why I know the basics. But when it comes to knowing a lot of things around the space, I don't think anyone can be so confident that they know everything. And this session is about teaching the basics. The bootcamp that we're doing with folks at IT Kharagpur, KDAG, is it's free first off, and it's very detailed. So we'll cover things there. I'm not sure why certain things are not loading. There is like, so for example, there's a KDAG logo here. I'm not sure why it is not loading, but okay, we'll park that for now. You can, I mean, if there is any, essential graphic that is missing, I will flag it. Okay. But for now, let's, kind of go ahead to understand. Now, Pathway, like to give you a quick introduction, it's an open source framework for data processing. It's the world's fastest framework supporting batch streaming and large language model applications. It's not in a tech, in case you're mistaken, that there's going to be like we will be talking about the bootcamp that we are running, but it's a free community initiative. There is no kind of monetary engagement that is involved in any of the aspects there. Why we do this as a as an open source platform is because while we're building awesome tech, we realize that we can't really remain the leaders in the industry without engaging with academia and without engaging with the community. Second, most of the folks at Pathway, they themselves come very like from a very deep academic background. They have been professors at some of the top European universities, so they love teaching. They have a knack for teaching. The third thing being that we totally recognize and realize this, that the change makers of tomorrow are not really in the boardrooms, but the dorm rooms at colleges like IIT Kharagpur. So it makes all the sense for us to go and interact and collaborate with really enthusiastic group like KDAG. That may sound very cheesy, but for us, we are quite fortunate enough to find such a group of enthusiastic folks who are extremely professional in nature. Um, Let me briefly explain what batch and streaming is, because I guess some of us may not know what those things are. Now, essentially, this is something that is very relevant for colleges. Okay, like think about it this way. So you are like, for example, you may be washing your clothes on a regular basis, right? There are two ways of washing clothes. One is that you accumulate all your clothes, okay, and you wash all of it at the weekend, okay, or in once in 2 weeks. Some it may be applicable for some of you in the case of bathing as well, but not to washing clothes. Okay, so let's consider the example of washing clothes at the end of 1 week or 2 weeks. Right? So you're creating a batch of dirt within your clothes, and then you're washing it all at once. That's typically a batch process. What is streaming? Streaming is not just the streaming that game streaming and all those things, but it basically means that you're dealing with real-time streams of data. Which means that in this case, in the analogy of washing clothes, you're washing clothes as as early as the clothes gets dirty. you are washing it right away and getting it ready. That's like real time. So that's what streaming data is, and LLM is large language model. Now, like most of us in colleges, we wash our clothes by the end of the week or by the end of 2 weeks. Similarly, in the world of products out there, most of the applications they work on batch data. Okay, like if you're building a project on your Jupyter notebook, for example, in the case of your data centers, or even if you are building an open source project, I think might disconnect it. It's still an issue. Can somebody please flag it? If that's the case, I'll get to it. But yeah, okay. So, like yeah, we would wash our clothes by creating a batch. That is what batch is in this case as well. It's about in the world out there. Most of the applications work on batch data. Essentially, you're not learning in real time like the way we humans do. Okay. Okay. There's a comment called yes from Ayush. I don't know if that's a yes for my issue or that's a yes for my work. If you can be more specific there, that will be helpful. I'm assuming that the mic is working for me. And if it's not working, then flag and I'll stop. We'll find the solution for it. But by the I'm looking here and again and again, because this is where I can see the comments and everything. Got it. Perfect. Thanks, Dipesh. So yes, so basically, in the real world applications out there, most of them use batch processing. For example, something like ChatGPT, our favorite large language model application, that is trained on batch data, okay? Which means that typically, like, it's not learning in real time. Something a real time example would be something like Google Maps. So for example, if I have to go from Mumbai to Delhi and there is some random disruption happening in a particular highway, I wouldn't have to wait for a software developer or a data scientist at the back to run a batch process for it to get updated. As soon as something happens, the map knows that this has happened and it nudges me, right? And this is not the best path. So that is streaming example. We're processing data in real time. Now this definitely involves a use case of parallel processing and relatively more complex to run. That's why traditionally, when you look at streaming applications, they've had a completely different set of tools set up. Okay. So, for example, Apache Kafka is a very popular Apache Confluent Kafka, whatever. These are popular streaming tools. There's something called as Flink as well, which operates at a lower latency. Something like Pathway is roughly 90 times faster in certain cases when you benchmark it against the incumbents, and that is where it becomes the world's fastest framework. And LLMs, why do we operate in it? Because we're able to do that as well, very well. But what aspect of it, we'll understand it later. Essentially, Pathway is built in Rust. The workflows are quite efficient. For those of you who are into competitive programming, interesting thing is like half of the team, more than half of the team members of Pathway, they are some of the best competitive. One second, let's not Bluetooth connected. Let me Um, okay, let's see if it is any better now. Okay, just allow me a second. I'll check if this helps. Um, yeah, I think it should be slightly better now. Okay, you can let me know in case it is not working. So it is. I mean, the key thing is like some of these people are some of the best competitive programmers out there. They include world finalists. Some of them are medalists. So from my code chef days, if I look at it, I typically describe these as red coders, as we know them. Some of the known faces that I worked collaborated with in the past when we were creating something like Code Chef Snackdown or problem setting for some of the best competitive coding challenges out there. And but the good thing is Pathway for using Pathway, you don't need to know Rust. You can use Python, and you can use it. So essentially, while it is built on, awesome, good to know that this is better. So while Pathway is built in Rust, it's exposed by Python. Why? Because Python offers a much larger community. It has a much better ecosystem compatibility. And as a developer or as a data scientist, you can use the same framework for doing all the three applications like batch streaming and LLM use cases. So you don't need to learn additional tech or additional languages for it. And in the case of a company-wise implementation, while most of you would realize that learning language is not the key achievement here, but the key thing is that if for a company, if you are having a different framework for all of these applications, that means that maintenance becomes a lot more difficult. Okay, so maintenance, finding talent, and everything. So this is where we have tried to solve the problems. These are some of the use cases that you can solve with Pathway. I'll skip it, but many of them are around LLMs that we have tried to summarize here. Okay, you can build your own chatbot. We are covering this one in this session. can ask privacy preserving queries to LLM with private knowledge base. Extend Kafka. Basically, you can connect with Kafka DBCM streams if needed. Okay. You can convert unstructured data into structured data at fly, which can be used in a ton of use cases. Okay. You can validate a stream of incoming documents. You can set up alerts in a corpus of data. Okay. So, for example, let's say we'll cover that. Okay. Let me go to that eventually. Okay, but let's understand the scope of the industry quickly. Okay, because we may or may not understand or appreciate it completely right now. So this we a lot of us believe that generative AI is a bubble. Like any other tech cycle, there is definitely a growth, and like there will be a curve that we will be seeing ahead of us. But recently, I think the CEO of JP Morgan and someone said that it's not a bubble. It's practically being applied in most projects. It's not that companies are not adopting it. Most companies right now, if you may be aware, Apple Car, they recently and Apple basically stopped their Apple Car project and diverted their workforce towards generative AI projects. Similarly, I was seeing this very recent podcast of Y Combinator. Y Combinator, for those of you who do not know, it's one of the world's best accelerators. Okay, and they were discussing about a lot of LLMs, a lot of startups that LLMs are, which are built in the use cases around LLMs, and they are essentially covering what we are covering in this particular session and in a much deeper level in the bootcamp. Okay, they are covering something called as RAG, retrieval augmented generation. Majority of applications, whenever we talk about using LLM for a particular use case, and it involves a frequently updating data, it will definitely involve what we're going to learn here today. Okay. And rightly so, McKinsey estimates that the Gen AI market will be pretty huge, adding more than $4.4 trillion of value annually, which is insanely high. And if you look at it from a company's angle, they need Gen AI tools like ChatGPT, like Google Gemini, with like previously Bard. They need these tools to work with data, that is private data, while ensuring privacy, security, optimal cost. These are very common concerns. Apart from that, while this data is getting updated on a real time, so that would need something called as real time vector indexing. What that is, we'll understand that quickly. And they are actually kind of trying to understand, get around this challenge of extensive manual effort, understanding, learning these things on a very quick note, and observability. These are some of the common issues. That is when they are turning towards people like young engineers like you, who are coming from industry, who are coming from the academia, to build some of these tools so that you can learn them quickly and build it for them. So this for you represents a very strong opportunity as a startup enthusiast, as a potential employee. We'll cover some of those use cases. In this session today, we are covering two things. One, we'll write our own LLM app in Pathway, and not Pathway specific, but in general, we'll try to understand the basics a bit more. We create our own chatbot and make it learn on real-time data, or make it work with real-time data. Okay. Uh, Now let's understand a couple of use cases for this first of all. Okay. Let's take this example where you are uh, you are the CEO of Netflix. Okay, and you want to understand that how is my revenue growth or usage growth happening in Kharagpur region or in West Bengal. Okay, now if you look at it, this involves a very interesting data which is available only with Netflix, and ChatGPT is not trained on top of it. Interestingly, there was some report which said that I think 40% of C-suite executives or something like that of these Fortune 100 or Fortune 500 companies, they use Gen AI tools. So now, if you want, these tools to give answers like this for some very high salary drawing individuals, it needs to act fast and it needs to respond accurately, right? But ChatGPT doesn't know how to do that. Second example is Mintra Chat, Mintra or something like Amazon. I remember Mintra had released something called as a Mintra Chat, where you can go on the app and you can ask, tell me hoodies that went on a discount over the past 1 week, and it will give you that. Now, again, you can end up using the API of ChatGPT, which is GPT, Chat Completions API. But then, how do you combine it with real-time data? It's not a simple Google search that is happening, right? Because in Google search, if you look at it, when you say Googling is a skill, that involves drafting the query in such a format that you're getting the right response. For example, you may want to play around with the site, put the right keywords. But when it comes to large language model applications, LLMs, they are supposed to be more efficient around semantic understanding, like around understanding the meanings. So, how do we go about it? That is what we'll understand. This particular session is largely possible because of these two friends of mine. who have prepared this a lot of contents around this. They frequently evangelize and teach folks. Bobor was previously with Pathway. He was a lead at Microsoft, and previously led initiatives at Apache as well. Olivier is still with Pathway. He's an R&D engineer. He's done his postdoc from Peking and done his PhD in Canons. Now, for those of you who already are in this field, they would probably know that the importance of Canons. Okay, it's extremely important and superbly relevant in the context of RAG that we're going to cover here. Okay, and yes, one quick thing is, since we are online, all of us, let's quickly hit that like button and subscribe the channel of Kharagpur Data Analytics Group. There's some really awesome folks, and I think this is the least we can do for them in order to support them. Let's do that. Um, Now, in this case, we know what ChatGPT is, right? It's like a typical example of a large language model application that we would have used. If it was an online session, I would have asked a few questions around it. But even in this case, it's very safe for me to assume that most of you would have used ChatGPT and would understand what prompt engineering and these concepts are. Okay, let me give you a very quick introduction in that case, in case you do not know. Um, ChatGPT is this large language model application. These are very large. They're typically supposed to do a lot of things. Okay, and prompt engineering is how you work with something like ChatGPT without some extensive, tool like RAG or fine tuning. You're not even going there. You're simply typing the right prompts. Prompts is what you give, like a hint, right? So, so putting the right prompts within something like ChatGPT to get the output. That is what prompt engineering is. A quick precursor to what we're going to cover ahead. So we know what, like, we'll cover what large LLMs are. We'll understand common ways to customize LLM applications. We'll understand what RAG and LLM app is, and along with the links to the GitHub repo and showcases. Okay. Uh, a quick thing. This is just a quick intro of the coursework that we are starting off. From next week onwards, it's 100% free again. There's no caveat there, no caveat for certificate and everything. There are in fact some prizes that you will be getting if you build up a very impactful project. The ownership of the project will stay with you. However, you will be required to build an impactful open source project, which must be open source, using the framework that we're covering. The things that we're covering is quite vast, so it gives you a lot of opportunities. Um, and some of the people who have created this thing, I mean, this actually does not do justice completely, because there are more people who are extremely competent, who have put in some serious amount of effort to make this happen. Jan, he's the CTO of Pathway. He has published papers with someone like Joshua Bengio and Geoff Hinton. If you do not know who they are, you can search for Godfathers of AI. Apparently, it's a thing as published by some of the top folks. These are some very leading folks, all Turing Award winners. Okay, Adrian Kosworski, he's somebody who did his PhD at 20, co-founded Spodge. If you have used something like CodeChef or HackerEarth, in the past they used to use the online judge of Spodge, like the evaluation tool. Spodge itself was a competitive coding platform. I don't know if they still use Spodge, but Spodge exists as a competitive coding platform. Anup, he's the growth head at Pathway, associated with Texas A&M. Sergey is a cool friend. He's the one who was with CodeChef earlier. He's a lead software engineer at Pathway. He's an IY gold medalist and has been head of service previously at Yandex. Yandex is the Google of Russia, in case you don't know. And then Burke is someone I reach out to from time to time. In fact, we were trying to prepare something around this coursework yesterday night. So, but yeah, there are more folks who have contributed to this. When you be a part of this boot camp, it will be very great if you can, you can interact with the community members, other folks there. These include some of the finest researchers out there. So try to make the best of the opportunity as you are getting it. LLM is moving forward. Like to understand what it does is, so an LLM essentially is I mean there are two essential components of LLM if I have to describe very briefly. First, it is large, as the name says. This is usually trained on a very massive amount of data. Okay, and the data and the data on which this particular LLMs are trained on, as we are advancing further and further, that usually ends up becoming larger. In some cases, they are trying to innovate on more spectrums as well. That is not a scope of this particular session. Spot is the OG, yeah, it is one of the OGs, yeah, correct. Um, but yeah, so sorry, got distracted with the comment, but yes. Um, Yeah, so LLMs, they're large, they're trained on a vast amount of data, and then they can do a lot of things. Okay. Like a single model can do your information extraction, instruction following. You can do translation, you can do summarization, you can generate images now. We have this thing called as multimodal LLMs coming on. What is multimodal LLMs? Like text is a mode of communication, right? So multimodal would mean that there are multiple modes of communication. Like you would have text, video, audio. So imagine a world where the compute power is increasing continuously, and the architectures are becoming more and more efficient. The data is becoming more and more efficient, and there is an excessive amount of money being poured in. It wouldn't be surprising, right, if we see GPT 5 or 6 working seamlessly with videos. Like if you look at the difference that we saw between GPT 2 and GPT 3, that was massive. Okay, even GPT 3 and GPT 4 was significantly different if you just compare them. And we're just comparing these closed source models. If you compare with open source, I think the impact will be superbly awesome. We are yet to see, we are not even close to what we are about to see in terms of the kind of impact these things will be creating. And in all the cases, it will involve the use of RAG and using LLM with external data. Uh, why? That is something we'll understand. But this is what LLMs are. Now that we understand it, let's move a bit further to see how briefly LLMs work. Now, they use something under the hood. They use something called as a transformers architecture and multi-head attention, which we are not diving into this, which we are not diving into in this particular session, and that's completely okay because that is not needed when you have to use something like an LLM to work with external data. There are other things that we need to understand, which we will cover in this particular session. Okay. Now let's understand very briefly how LLMs work. Okay. Let's say you have a prompt like KGP is in which state of India. Okay. Now you'd typically heard that LLMs are very good at understanding context and predicting the next set of words and giving the output. Predicting the next set of words, we don't typically hear it very often, but yeah. So what happens is, let's understand this very quickly. Essentially, whenever you enter a prompt on something like ChatGPT or Google Gemini, that particular prompt, there is something called as a tokenizer working in the backend. That tokenizer breaks this into words and subwords. Okay. So this thing will be broken into words and subwords based on the semantic meaning. And each of those tokens will then have a meaning to it. Will then have a numerical value associated with it, like a matrix. This matrix is typically like a multidimensional uh, what is that we'll cover very soon, but consider this that this particular text is then converted in a numerical format because essentially if it's a machine learning model, it has to work with numbers, right? It can't work with text. So imagine all of this getting converted into broken into tokens and then converted into numbers here. Now what happens here, we have written in a textual format, so it's easy to understand. So what happens is, let's say there's something like this that has been broken down into tokens. Now what LLMs do, what transformers architecture enables you to do is process all of this simultaneously and give much more efficient outputs. What happens is, let's say once you've broken down this particular thing into tokens, all of this thing is ingested into the LLM. Okay. And the job of this particular LLM is just one job, and that is predicting the next best word. That is the primary job. So let's say Kharagpur is a city in the state, like that. Let's say that's giving that. So generates in the okay. Then once it generates Kharagpur is a city in the, it will again take it and put it in the LLM and try to give the output as in the state, and then again put all of it in the state of, then give it, and then you typically get that output in the form of numbers, and then that is basically nothing but tokens, and that tokens is then converted into detokenizer to give the output. Kharagpur is a city in the state of West Bengal in India. Yeah. So that is a very brief and superficial description of what LLMs do. But essentially, it is important to understand at this point that there are two things. One, there is tokenizer, detokenizer. Second, we are converting this into a numerical format in which this processing is being done. It is also called as vectors, by the way. So whenever you hear things like, if you've heard of things like vector databases, vector index, vector embeddings, it's all related, and it is nothing but a numerical representation of every word in a multi-dimensional space. Okay. Now we'll visualize that better, but let's understand a particular use case of Amazon, for example. Okay. So let's say you want to ask, like, can you find me discounts this week for Adidas men's shoes? Let's say this is a query that you have to ask. Now, why can't you use ChatGPT's interface for this? ChatGPT is very smart, right? But if you ask it, can you find me discounts this week for Adidas men's shoes? Is that, I'm sorry, I don't have real-time browsing capabilities or access to current promotions. However, blah 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 blah. Now, this doesn't solve the problem that we are trying to solve, right? So, the other option that we have is basically around uh, there are around fine tuning or prompt engineering until you understand the concept of RAG. So, the thing is like, GPT excels at answering questions, but only on topics it remembers from its training data. If it's not in its training data, it won't be able to understand that. Okay. So recent events after okay, this is slightly outdated thing, but yeah, depending on whichever model you're using, there's a cutoff date for these LLMs. What does that cutoff date mean? That basically after that it does not have the training data. It does not have access to your non-public documents. For example, I'm the CEO of Netflix. Okay. Interestingly, when I was working in my first company, that was DirectTime. In DirectTime, we had data analysts whose job was just to simply pull the data, create dashboards, and give it when Bhavin, who was the CEO of Data, would ask for it. Okay, and that is basically like simply what they're doing is they're simply pulling the data, putting it in a structured format, so a CEO can understand and feeding it to them. That's the one of the core aspects of job, and you would be surprised to know how many people in the industry do that. Now, if you look at it from the Netflix CEO example, that's a good enough thing to be simplified with the help of LLMs, right? Or some examples are like, for example, um, like booking your weekly laundry thing. Okay. Or let's say you have to travel on a regular basis from point A to point B, then booking your Ola cab or booking anything like these mundane tasks, which are very repetitive in nature, which are not so efficient actually. Or like, for example, one thing we have done this particular showcase. It was extremely popular where let's say you as a lawyer you have a lot of folder documents in your SharePoint or Google Drive folder, and you need to maintain every single nitty-gritty from each of those in a Google document, in a Google sheet. That when is this signed, who is the signatory, everything. Or in the case of research, let me take this example. I've seen this very commonly. All of us would have done it. Like we have to review a lot of research papers, and then we may be trying to find a very similar element in all of those, whether they have used this technique or not, or whether they're using this or that. This some of those questions can be more complex, but many times those questions are also very basic. You're doing a very redundant activity out there. Okay, and then the example of real-time data. For example, if right now, as we speak, certain companies, some very big companies in Europe, they use Pathway for communication. In fact, in Olympics, Pathway is being used for enabling real-time communication. So, for example, it's like let's say you're in the city of Paris, you're using something like Transdev or any application, and you want to ask in French that tell me how do I go from point A to point B. Now, their bus routes keep on changing very frequently. Some of the bus will get cancelled, some of them will get delayed, random stuff, and somewhere some protest is happening, somewhere some event is happening, a reroute, detour, everything. Okay, and those things happen in India also. Just that we probably are habituated. Actually, our transport is good, but still you get the point, right? Now, all of that can be very well automated with the help of LLMs. We can make it very seamless for the end user. Okay, and technically, as Indians, it actually presents a very strong opportunity for us if you are able to combine the power of real-time data with large language model applications, which are built for native languages. Okay, because most LLMs they are not built for Indic languages. So if you are able to use if you're able to use a fine-tuned model, or if you're able to build them for native use cases, you can actually unlock a lot of opportunities. One particular startup that I'm a big fan of is ShareChat, which is built on this premise itself. They don't use LLMs; they heavily use streaming, they heavily use vector embeddings for recommender systems. But I don't know if they're using LLMs, by the way. But these other things I know. And the key thing that they had as a proposition was straightforward, that it will work with native languages only. Okay, and then it is one of the biggest startups in India, and probably one of the only social media companies that have become really big from India. Okay, so something to be happy about. Now let's understand what are the options when it comes to using LLMs with real-time external data. One option is that we are fine tuning. Okay. Now, what is fine tuning? Fine tuning is basically you have a label data set and you're you're optimizing your already available LLM for that particular task with the help of that label data set. Okay. Now, uh, this may seem like a very intuitive option given that until now, till the point we were not dealing with large language model applications, one of the most common things that we used to see was fine tuning. Okay. In fact, right now when you go on Hugging Faces, you'll see a ton of models which are essentially fine-tuned versions of something like Llama 2, and which is okay. Like you can fine-tune. popular or Mistral 7B. You can fine tune these models, right? You don't have to start from scratch. That's okay. But when you have to use this in a production environment or in a use case where you need to work, you need that to work with real time data, there are certain challenges that you will face. For example, data preparation challenges. Okay. Then there are challenges around cost efficiency, like and data freshness. Now imagine like you can prepare a label data set once, right? But if you have to do it and like every single day on a regular basis, that becomes super difficult. And as a company, that just doesn't allow you to keep up with the pace of ever refreshing data. So now, how do we make it happen? Is where we try to cover this particular element of uh, another alternative, which is prompt engineering, the one that we covered. What is prompt engineering? You basically try to copy paste the data, you put it on the LLM and tell it to give that output. For example, uh, given the following discounts data, answer this particular query. Okay, you'll simply copy paste that particular CSV and get the answer. Okay. So, for example, if you copy paste it may end up giving you something like this. I can provide you with the details basis what you've provided. That's fine, right? But if you think at it from the CEO of Netflix perspective, the use case that we discussed, or more things, is understand it has a few challenges. First off, if the message becomes very long, it will throw up something like this. That the message you submitted was too long, please reload the conversation and submit something shorter. Right? You would have seen this. Uh, so this is basically because there's something called as a token limit. Now, what is token limit? If you remember, we saw detokenizers, tokenizers, right? So um, we're talking about, imagine it this way. We were discussing about ingesting the entire data into LLM, right? Like, for example, you type something and all of it goes into LLM altogether. It gets computed and the output comes in. Naturally, there is only so much that can be done, right? So there's something called as context window and token limits of every LLM out there. Okay, if you exceed that, it gives you this particular message. Try copy pasting the Wikipedia page of Google, for instance. And this token limits is different for various models. For example, there's a token limit of some of the state of the art models that exist today, which are very popular. GPT-4 has a token limit of 32,000. GPT-4 Turbo has a much higher token limit, um, but that has higher costs also. Okay. Most companies right now they find it expensive to use GPT 3.5 also. Interestingly, most Indian companies. Okay. Then you have Llama 2, which has a much smaller token limit, and Cloud A2, which is by Anthropic. That's that's slightly bigger. Again, these best use cases, these keep on changing. It's a business. Everybody's in this business. They are trying to make every LLM work for every use case. This keeps on changing, but for us, it's in this case, it's for us to understand that these things exist, like these constraints exist on a technological level. Okay. Now there are certain challenges. Let's quickly understand. So one is manual work. You're copy pasting the entire thing. There is a limited context that the LLM will have. Third, it is unable to save data for future use. Like if you have to tell a particular output from time to time, or 10 users are asking the same thing, everybody will have to copy paste the same thing, right? Which is not the efficient way to go about it. It is impossible to store the result or expose the result, and there is no access of real time data. And one more thing that I missed to mention is around privacy. I mean, if you're the CEO of Netflix and you're going and copy pasting your revenue numbers on ChatGPT, that particular tool openly tells you that it will be using it for training the models. If you're using normal ChatGPT basic version and something like Cloud 2, for example, I don't know if it is now allowed in Europe, but earlier it was not even GDPR compliant. In a lot of places like India and others, it was allowed. Even I think in the states it is allowed, but still, if it's not GDPR compliant, that's a red flag, no? So as a company where data is so sacrosanct and important for you, if your executives keep on copy pasting things like this in a public platform, that's an issue, right? You can't end up exposing your private data at this particular scale. Okay. So how do you make it happen? That is when the context of RAG or retrieval augmented generation comes in to picture. Okay. So RAG is what we are covering in this session essentially. If somebody asks you what we covered, it's essentially RAG. Most applications that YC folks, YC Y Combinator folks are talking about, they're advanced use cases of RAG. Most applications that Pathway makes, interestingly, by the way, a humble brag. Some of the good Formula Win teams, they use Pathway for processing real-time data. Half of the parcels today, in a way, they are delivered with the help of Pathways frameworks. Keeping that humble brag aside, essentially, the point here is that even Pathway, their team makes a lot of see a lot of production level applications that companies use, which are around RAG. Okay, and many of those applications you can build as an individual. Now, what is this thing? This example is an interesting one. I have a GIF also for it. In this case, I don't know why it's not playing, but you remember the scene from Mr. Bean, right? Where Mr. Bean is trying to copy from this particular individual who we never know who this person was. But the idea was uh, Mr. Bean, like an LLM, okay, has some knowledge apparently, and he's supposed to write the answer. Okay. Now this is a document corpus. Imagine it this way. Now he can't go into his head and copy paste the entire thing. There's a context window and there is time issue, everything. So what it will do is it will just retrieve what is important. Okay, it will not copy paste the entire stuff. It will just retrieve what is important, process it, and then put it in his own words. Okay, I don't know if the latter putting his own words, knowing Mr. Bean, he would have done it. But the point being, what RAG does is, if in a magical way you can simply retrieve the most relevant information that the LLM needs to answer user's query and simply augment the prompt from the backend, then you can end up giving that answer. Let's understand this further. Okay. So RG basically has three things. It has retrieval, augmentation, and generation. First of all, it sources the most pertinent information. Okay. Then the next thing is that this information is added to the model's initial output. Okay. Input, sorry. So for example, if you're asking give me the revenue numbers, then what it will do is it will simply fetch the revenue numbers for West Bengal, okay, instead of the entire context, and then feed that into LLM in the backend in the way saying that, you know what, Mudit or Reed Hastings or anyone is asking for this particular number, and you know what, this is the number by the way, just that particular input, and then the LLM generates because now it has the context. That is what RAG is. Okay. And this sounds simple, and essentially it is actually, given the kind of things that you all folks can do, it is actually very interesting of the kind of things you can execute with this. Okay. But let's understand a key component to make it happen. Like, how does this retrieval and augmentation happens? If it was so easy, why doesn't Google do it very well, right? There's this very cool startup, by the way, called as Perplexity AI, founded by folks from IIT Madras. Not folks, one folk from IIT Madras. But yeah, I mean that uses RAG essentially at the crux of it. It is able to give those outputs in a much better manner. And why? That is because of something called as vector embeddings. Okay. Now, let's understand this particular component. But before that, let me take a small break to have some water. Meanwhile, if you have any questions, please put it across. I'll just mute my camera I'll just shut on my camera for a minute. If any questions, put them in the comment section. I'm having a look at it. Okay, no questions so far. Cool. Ah, okay, now let's understand vector embeddings. Okay. Yeah. Okay. So what are vector embeddings? Essentially, the idea, if you remember, when we discussed earlier, when we are talking about the working of LLMs, yeah, we said it breaks the this one. In this case, we said right that the context, the particular thing is broken down into tokens, and that is somewhere processed in a numerical format, right? Similarly, vectors is where you typically do them where the magic happens. Okay, so what you can do is essentially you can convert vectors is nothing but numerical representation. Okay, yeah, vectors is nothing but a numerical representation of a particular kind of input, be it text. For text, you have text embeddings. By the way, the words vector embeddings, they are interchangeably used. Okay, so if you hear them out, know that these are same things. Just a second, yeah. I realize why I'm feeling. I'm, by the way, not in West Bengal right now, and it's a bit warm here. So, just, 1 second. Yep, I'm back. So, now for audio, you will convert that into. I've seen a question, by the way, Pratham. We'll pick it up. So, in the case of audio, we'll convert that into audio vector embeddings, text into text vector embeddings, and videos into video vector embeddings. Okay, and the job of this is particularly that you're storing this particular information in a multi-dimensional space so that the semantic information is very well captured. Now let's understand this. There's a room behind me, right, that you can see. Now, let's consider it this way that whenever we create vector embeddings, the idea is to group similar items together based on the meaning. So, for example, something like and uh, a cat and cat woman will not be put together, okay, because they do not have a similar meaning. But a cat or a lion, which is from the same family, I believe, they'll be kept together, okay, or something like man and woman that will be kept together because they are usually having a similar meaning, okay. Um, So essentially, something like and when you basically put things together with similar meanings close to each other, we are basically making it easier for a particular model or a particular retrieval mechanism to find the most relevant context quickly. And that is where the idea of KNN also comes into picture. Basically, you're doing a K nearest neighbors. That is what KNN says, by the way. You're doing a similarity search, trying to find similar things from a massive corpus of data quickly. So it can be retrieved efficiently and then put it back. Okay. So let's understand this particular concept of multi-dimensional vector space. Now imagine this is a room here, right? Now we would typically imagine a 3D space. So length, breadth, and height. Okay. And the diagram ahead is something that I picked from this particular project put on Hugging Faces, very neatly put. Okay. Now in this case they're not using what do you call it? Um, they're not using words, but they're representing video stuck, is it? Okay, I'm just switching it to and fro, so you can let me know if that transition happened or not. Okay, this is a dynamic thing, but it keeps on hanging at times, and whereas and anyway the Canva is a bit is acting up a bit today, so I'm not directly opening it up on. No, it's good. Okay, cool. Thanks, Matthew, and thanks very much for flagging it in the first place. Um, so in this case, okay, in thanks, sir. Okay, so in this case, what we're doing is in this particular diagram is this particular person. What they have done is instead of representing meanings, they have represented colors, organized them in a 3D space. Okay, so that similar looking items are grouped together. Okay, so if you look here, this Kelly green is similar to other forms of green. Like, and I can show this particular project, but I'd rather not because it tends to take some time when I'm sharing my screen. I've tried it in the past, but yeah. But essentially, if you look at it, what is happening is that things that are similar in nature from a meaning standpoint, they are grouped together, right? In a in a 3D space. Now, what does 3D mean here? It is a 3D space, right? For example, there is RGB, three dimensions. Okay. But if you consider a multi-dimensional space, that would mean like let's say there's this x, y, z coordinate. There's one more coordinate called as x dash, y dash, or like a, b, c. There are multiple dimensions, right? So in that particular format, for example, how you can possibly represent Kelly green in this case is like 76, comma 187, comma 23. That's a 3D vector, like whereas where you're capturing it into three dimensions. Now, in a multi-dimensional space, you will capture it into a much higher number of vectors, and that will help you with these outputs. Okay, that will help you capture the semantic information in a very precise manner. Now, there are various ways of encoding, like various ways of converting text into a numerical format so it can be computed. Why did we stick with vectors? Because it was observed that vectors usually have a lesser dimensionality. Like it may seem to you that we're talking about multidimensional, talking about 200 plus dimensions, like 200 plus rows in a particular matrix for a single word. But that's a lower dimensionality. And that is quite efficient in terms of capturing the semantic information. Semantics is nothing but the meanings. So that is why we shifted to something called as word vectors or vector embeddings. And all of this actually came out with this seminal paper called as a word to vec. Let me quickly, show that once again. Hmm. You can go and check out this particular paper. It was published by folks at yeah Google previously. And what it does, they did is this was the first time when they had demonstrated such a power of word vectors, and they had shown this in a numerical format. Where if you look at it in in this particular space, things with a similar meaning are grouped together. Okay. And essentially, if you look at it, there's a very popular example that you can play around with. Um, this is like a multidimensional space. There is an example around using with, I think this is the one. Let me see. No, not the one. Okay, we'll skip it. But essentially, with this particular paper is where the concept of word vectors came into picture. After a lot of evaluation, we've seen that this is one of the best ways to capture semantic information. And essentially, what you're seeing is that you are converting that into textual format, grouping it together as per their meanings, so it can understand the context very well. That is fine, but doing this always involves a layer of optimization. Like you can always do this even better, and which is why creating more efficient vector embeddings is a constant pursuit. Like that's a domain where people are constantly working on. Okay, like how to prepare more and more better vector embeddings, and this actually helps in capturing the contextual information very well, because when you're storing something in a vector format, you can judge things by the meaning and not purely by the not purely by the intuition. For example, let me show you an example. Let's say this is my Safari, right? Okay. So like if you typically ask like okay, Google, I don't know if it will work. If you do a quick search, like let's say we are using Google Gemini here, it won't work. My pathway account. But oof, if you quickly use something like um okay, what is the color of Apple? I don't know. Gemini has, by the way, improved quite a lot. These LLMs are improving significantly. Okay. Now it will give an answer like the things that we know of, right? Yeah, cool. It is giving this thing. Now let me tweak it a bit. What about the color? No, I'm talking about the brand that makes iPhones. Okay. So the thing is essentially I'm showing the importance of context when it comes to LLMs. Okay. When it says sorry, I got the color wrong. Okay. But what is the color? Okay. Technically ChatGPT would answer this, but yeah. And then it will go on to say silver, space gray, whatever. Okay, I've tried this in the past. The black and white, other colors, silver, multicolored. See, so similarly, something like bank, for example. Now, bank can be river bank also. It can also be something like a financial bank, right? HDFC Bank, all those things. So uh, you basically are like storing these things in a numerical format, grouping it, and as per the context that it is put in. So whenever you're ingesting that entire context of information in an LLM, it is retrieving the most relevant information. What is vector index? Vector index is an index. It's not necessarily a database. It's an index where you're storing all these particular vectors. And the idea is that it can forget things very easily. Okay, it can adapt to a live data stream. You have full control of it, and it is private. So you don't end up exposing a vector index. For example, what I can do as a developer is if I have to simply retrieve things, I won't put that into the context of the LLM right away. Okay, I will put it in my private um, infra. Okay, and I will just retrieve the most relevant information and put that across. And even the LLM can be hosted on my particular cloud if I want to. Right. That way, it ensures privacy and full control. Okay. Um, RAG, what it does is basically the step one is now let's understand the steps involved in RAG. First one is computing the embeddings of a query. Second is finding the most similar document using vector index or vector database. And third is prompt engineering. Like these are the three elements around it. Okay. Um, okay. So for example, let's look at this particular architecture diagram. Okay. Whenever we execute this, this is how we execute it. Okay. Typically, you have, let's say, a live data source. Okay. This data source can be a variety of things. This can include, okay, let me zoom in. Yes, it should be bigger now. Okay. So let's say you have a live or static data source. This can include your PDFs. Okay, it can include your cloud storage, Kafka topics, DBSM, PostgreSQL, anything. Okay. Now, first thing is basically uh, using this particular data and converting that into vector format. And for converting this into a vector embeddings format, there are a lot of LLMs are also used, by the way, quite commonly for converting this into an embedding format. Okay, so when you use something like an OpenAI API platform, for example, you will see there are two kinds of APIs available. There is a chat completions API. I mean, there are a lot of APIs available, but in this case, there is a chat completions API which you are using ahead, and then there is primarily a embeddings API. There's a proper leaderboard on Hugging Faces where, by the way, you can see which kind of embeddings are good for which use cases. There is no one size fits all kind of thing that happens here. There are so, for example, and this is a constant pursuit where you would see that this thing is being improved by companies continuously. There are more and more better embeddings model coming into picture. Okay, but right now many companies tend to use OpenAI. And this particular project that I built here, even I was using OpenAI embeddings because it is simple, it is hosted, and essentially, yeah, it's reliable, it works. Okay, and when you look at LLMs, a lot of times when companies are building projects, their goal is to do some validation instead of building a like a production ready built for massive scale application on diesel. Like first, I would build an application, test it with 1,000, 10,000 users, 100,000 users, whatever be it, and then see if it is of utility or not. Once it is of utility, then I will go for my LLMs, right, which are probably open source. And if you are a large company which is probably focusing more on output, then you may not even want to focus on these elements. Like for example, I know some of the projects that folks at Pathway are working on. They're quite cutting edge, and that does not involve like cost saving is important, but that's not the priority on diesel when it comes to embedding generation. Okay, so we use something like an embeddings model API here. In this case, OpenAI embeddings, and then we convert this into an vector embedding format. Okay, now this would typically end up becoming a matrix, and then this is stored into a real-time vector index. Okay. Now that real-time vector index is nothing but a collection of vectors in a format where similar items are grouped together. So retrieval is very efficient. This grouping together is very important. How you're clustering them is extremely important. And in the bootcamp that we'll be publishing as a bonus resource there, we included this like one of the key things how this is done, implemented within Pathway. But this is a very key component as a whole. How do you create an efficient vector index as well? Then at the same time, let's say when as a user, I am asking a particular question, like, let's say my question as a user is, let's say I'm a customer support executive at Pathway. Um, and I ask this particular question, explain how our latest product release can help the customers. Imagine this, like I am a customer support executive. I have no clue what streaming is, or let's say by somehow means I understood what streaming is. And now the developers they keep on releasing one thing after another, and they expect us to keep track of it. And our users are asking random questions which are very complex. How would I know on earth what is released last week? Okay, and this is a very constant tussle, by the way. Like I remember days when we used to have these debates around, this product release has happened, and so team was not aware. How we can make communication better, blah blah blah. It's a constant thing, right? So this is like an interesting thing to solve. So what? Let's say as a user, you ask this particular question, and you ask this via typical UI. UI can be something like Streamlit. If you don't know what Streamlit is, by the way, Streamlit is an ultra popular tool that is used by data scientists for generating the UI for data applications. It's a Snowflake owned product, quite popular. You should definitely check it out. It's also Pythonic in nature, so easy to use given a use case. So let's say, or even ChatGPT, let's say you have built something like that. You ask questions on that particular tool. Now, the retrieval mechanism, what it does is, now there can be various ways of retrieval. Essentially, when you're using a framework, they have their own built-in retrieval mechanisms. These frameworks can include something like LangChain, Llama Index. Pathway also has its own framework. Okay. Uh, the advantage of Pathway's framework, I'll tell, but um, yeah, but right now, it's more important to understand that what you're doing is you're converting both the prompt of the user and the data in a format in a similar format, that is vector format. Okay, and then what the retrieval mechanism will do is based on the query that the user has given and the data, it will do a similarity search and retrieve the most relevant information. That in this case, okay, uh, it will retrieve that okay from the version 2.23 product release notes. This is how it helps. And then what this does is it augments the context. That is why the word documentation. So essentially, when the user had asked, tell me how to, you know, uh, what does the how does the latest product release help my customers, then essentially what it will do is it will tell to ChatGPT's completion API that what this person is trying to know, how to generate what how does this help our customers, and at the same time this is how it helps. From the backend, it is giving that particular information, and then on the interface you get this particular output like saying ChatGPT or Streamlit that this is how it helps. This is precisely how RAG works. So essentially, we're dealing with two kinds of APIs here. Whenever you're building a project, the two APIs that you'll be dealing with, one is embeddings API, then is chat completions API. Again, if you're dealing with multimodal LLMs, then it will increase the complexity. Maybe you can go step by step to kind of progress with it. Okay. Now, essentially, yeah, where does Pathway fit into the entire sort of picture? One, because if you're using, there are two things. One, the framework that Pathway has, the RAG framework, that can do all of these things within the blue box. Okay, not the stat completions, but like the real-time vector indexing, storing that efficiently, retrieval, and then those things that can be done very efficiently with Pathway. If you're talking about using multiple agents, like for example, you want to use multiple LLMs running in parallel, that would involve some very good level of data processing in that particular case, and Pathway being a good streaming framework solves that problem very well. When you typically use Pathway with something like Llama Index or LangChain, essentially what you're using it for is for data processing, for converting that unstructured data into structured data and storing that in a vector format. Okay, so Pathways framework does not require a vector database, by the way. So what is a vector database? It's a database dedicatedly built for storing vector index. Now they became quite popular, like things like Pinecone, VV8, if you've heard of them. They became quite popular with the advent of these LLMs because one, they were already used in the context of recommender systems, and second, when the LLMs became popular, RAG became like a go-to thing for every use case almost. Companies were like, okay, fair enough, we need to use this, and they directly flock towards vector databases. But this is a problem for companies because they can't go about using databases just like that. If you're a developer at a big tech company, that can involve getting a ton of approvals, and every new tool that you're using that adds a layer of complexity and a layer of cost. So you might want to go for a more efficient approach. That is where what Pathway does is it basically creates a vector index and stores it in a persistent storage within its program memory itself. So essentially, you don't have to use an additional vector database, and it ends up working. Um, yeah, that is what it is. So this is typically, let me show you a cleaner code that, I mean, this is also clean, but just a second. Yes. So by the way, so far if you have any questions, let me know. I'm opening this in a parallel tab, the other screen. If you have any questions, just let me know. I'll try to answer it. Okay. Um, 1 second. Let me show it to you, by the way. You can see my screen, right? Yeah. Let me show you an interesting use case. So typically, when you have to build your first application within this, it's quite easy. Okay. Like if you search for LLM app pathway or LLM app, it should typically come across. Make sure you're starting this. It's really your way of like subscribing to a YouTube channel. Oops, it doesn't work like that. That's a GitHub thing. But maybe I'm just being a bit too impatient. Yeah. Uh, oof. Okay, I'll skip it. But essentially, if you scroll down, you will be able to see how to build your first application within this. Like for example, this is an interesting use case. Became quite popular among financial companies. Like you have this massive corpus of data or financial documents, you can convert all of that into a structured document in a SQL format. And then once it is converted from unstructured to SQL, then you can do a ton of things. There is a recent company which is entirely built on the Shopify itself. Okay. I don't know if they use Pathway or not, but yeah, you can also build a similar thing on your own. Okay. Um, Essentially, if you have to use your build your first project, right? This is the step-by-step approach. Let me show you an API .py file for you to understand how this particular thing works. Okay. Let me quickly check, by the way, if we're able to see the screen or not. I'll go to the streaming platform you're using. Okay, I do see a few questions. and we will answer that. Uh, okay. So essentially, for now, let us look at this particular example where we are using Pathways LLM app framework for creating an app that basically retrieves most relevant information from a Dropbox folder. Okay. So first of all, what you do is there is something called as chunking that is involved here. Okay. First of all, what is chunking? Let's say when you have to one second. Let us go to this example. Yeah. By the way, the thing that we're seeing right now, I think it's no, it's this one. So let's say if you're looking at this particular example, whenever you have to store it in the form of a vector index, right? Yes. Whenever you're storing it in the form of vector, so sorry, I was just distracted by a few questions there. So yes. So typically what you do is this also involves one more step that we have typically skipped in this case, and that is chunking. Okay. Uh, it is mentioned in the textual format, not in the diagram. Text is extracted from the data, chunked and converted into vector embeddings. So this chunking is a very essential part. The more efficient chunking, the smaller chunks you create, and the more efficient they are. Chunks is nothing but, let's say you have a very large information, right? You will basically break it down to a smaller piece of information so it can be processed. Okay. So you convert that into small chunks first. Okay. Then you compute embeddings for each of this using an API, like can be OpenAI APIs in this case. The next thing is simply creating a vector index from this thing. Okay, if you look at it, the code looks simple and it is actually simple. If you're creating a basic RAG application, it is very simple. And the bootcamp that we will be running, even there, you will be able to build these things. You can actually go a step further to make some really cool products. It is not meant to be complicated, actually. Then you generate a query using embedded queries and then generate the response with the help of, okay, generate embeddings for the query from this thing. Yeah, responses will be generated with the help of a few things. What is one is vector index, embedded query, and PWS query. What is PWS query? Yeah, this thing. So basically, you are getting the got it. So you're basically retrieving the most relevant information, and then using that retrieve information plus the prompt, you are basically getting the response. Like a response writer responses, feed the prompt to ChatGPT to get the answer. Yeah. Yes, fair enough. Huh, got it. So you're first of all creating the response to the augmented context that we were talking about, and then you're running this particular thing. And if you want, you can simply end up connecting this with a Streamlit UI quite simply. So a good use case to show here will be like this one, Dropbox. Yeah, chat. Just go to this one. I think this has a very structured way of implementing it end to end. You can also do it on your own if you'd like to. In this case, this project, what it does is it simply connects a Dropbox folder with using RAG with LLMs. Okay, so you can simply drop random folders into it and then ask questions. Now, how does this help you to build applications? It's not real time because in Dropbox, if you're dropping, yeah, if the documents are updated continuously, then it is real time. But if it's not updated continuously and it's a normal RAG basic application, then in that case, the way it can be used is, for example, one person, what she did is she basically was an developer advocate at Atlassian. Using this LLM app itself, she basically used it for deciphering the European Union AI Act. So what they did is they basically put the data, this particular documents around the EU AI Act and put them in a Dropbox folder and simply expose that via custom UI, so that understand how EU AI Act is developing. Okay. Now, if you think at it from a user's perspective, if something, a tool like that is updated daily, okay, and it's not updated in real time, it's updated daily, which is typically a batch process. But still, from a user standpoint, it's a useful thing to know, right? We can simply build those kind of applications with that help. Okay. And how to do that in a step-by-step format that is pretty much explained here. You can run it by simply cloning this repo in the first place. If you want to do it from scratch, then you can also find the API.py file, which is the one that we covered right now. Think, yeah, more or less. You connect for connecting something like your folder and all, depending on the tool that you're using. Again, with most tools, you will have some form of connectors. For example, if you go to Pathways data connectors, you will find, uh, let me go to pathway.com. Okay, I'll show you how this particular thing works. Depending on, like, if you're using Llama Index, in Llama Index also you'll find. some of the tools that are out there. Like on the typically in the documents, you will find okay for developers. Yes. Wait, I'll simply go to the thing only. Index. Yep, docs.llama index.ai. Okay. So if you look here on the left side, you will see a lot of things around loading data. Okay. So around loading data, you will see a lot of ways in which you can load the data. Okay. For any framework that you're using, let me show you within Pathway how you would go about doing that. There's nothing complicated per se within that. If you come here, if you go to the left, how to connect the data. For streaming, essentially, Pathway is one of the best ways that you can go with. It's extremely simple. Otherwise, it becomes a bit complicated. You can simply use Pathway end to end for building the entire application as well. You would typically couple it with something like Llama Index when uh, you have a certain bias towards a particular tool. Like obviously, me being from Pathway could have a certain bias. Second thing is because your company is using a particular tool and you want to use it with streaming, and you're unable to do it within the framework that you're using. Because something like Llama Index, LangChain, all those things, they would require you to use a vector database separately. Okay. Now, the problem with vector DB we have already discussed. With Path, you can eliminate that step. It is not needed for a considerable level. Okay. Let me just check the connecting bit, right? This should be done. Yes. So, yeah, connector, sorry. So, there are a lot of ways in which you can see how to connect a particular format like JSON lines, database, Google Drive connector. So, you can practically end up building a lot of applications with this itself. Okay. And let's go back to this thing. Um, Sorry for my unorganized tabs. So this is what we saw, like how we would typically end up building this particular thing. And in this case, the application that we saw, the Amazon one, how the particular person has built, I'll also show that particular repo. I'll post the link here on the chat, or you can Google it as well. It's called ChatGPT Python Sales API mobile, something like that. I think it should come up. Yes. Or let me put how to build um, an LLM without MongoDB. So that's a very neat, yeah, this is in Google for this one. This is a very neat blog that you can read. Okay. This has a step-by-step process of building what we have covered in the context of Amazon, the example that we're talking about. Okay. The architecture here is quite similar if you look at it. You have basically have data sources, you're converting that into embeddings format. You have front end, and you're using a chat completions API, and you're using a embeddings API. You're using OpenAI twice, basically once for embedding, second for chat completions. And here in this case, if you look at the example that they have shown here, basically they have covered two use cases. They are uploading prices information via Rainforest API. Rainforest API is a very popular API. If you Google it, you'll find it. For uploading, they're using a CSV as well in parallel. That is for showing that it can work with CSV, not because you need it. Okay, and then you can ask it and it will work. Okay, these things. Again, by the way, the kind of UI that you can have for LLMs, that is something which is very interesting in itself and an emerging field. For that, we have linked a few resources in the bootcamp. Okay, and the step-by-step process, if you look at it, if you simply search for this particular thing on your mobile phones or whatever that you are using right now or laptop, you will be able to pretty much find it. This is the title, like build a real-time LLM app without vector databases. Should work. Okay. And search for Streamlit if needed. Okay. Essentially, this is all the code that you need for building it up. Okay. Cool. Now, yes. Okay. Let me quickly complete this thing and then I'll pick the questions. I see a lot of questions from Matthew, which is awesome. Others also have a question, then they can simply ask. Okay. Sorry, actually, I've been speaking for a long while. I had a session before this as well, but I'm quite glad that I'm interacting with you all. So, yeah. Now, in terms of the boot camp, uh, as I said, there's no caveat here. Just the idea is the boot camp is not a rushed away way of learning, like where we are trying to consume a lot of information in this 1.5 hour session. This is an intro session for you to understand what all things we'll be covering in the boot camp. By the end of it, you will be able to build your own application, which is production ready, which you can use. If you're able to build some startup out of it, awesome. If you need help of Pathways team and in the Discord channel that we'll be creating for the bootcamp, if you ask us, we are more than happy to help you build an application that has a real world impact. As developers, nothing, makes us happier than seeing some awesome folks creating impact with the tools that we have built. That is the happiest thing, right? So, if you're trying to build something on those lines, this is a good opportunity for you. Even if you're trying to build a project, or if you want to showcase a use case of streaming with LLMs, great thing. Usually, companies do not expect students to come up with a streaming plus LLM use case. If you're able to do that, that is great. Link for the blog, please. Please, yeah, I'll put that in the comments. But you can also search it, right, Pratham? Like I'll put it anyway. Let me do. Okay, put it here in the comments section, and I'll also put this particular. This repo is not needed. LLM app, you can search for this thing. This thing, the if you search for the LLM app repo, it has a lot. This is a good showcase, not like that. But this particular repo has a massive set of really cool showcases. By the way, every open source framework, if you look at it, it has something called as examples. Okay, so there you can see a lot of examples that are uploaded. This is just one of the examples that we saw. Now, and how to run the examples and everything, those things you can find within the repo itself. Just spend some time reading it, or else join the boot camp, which we are coming back to next. Um, so essentially, in the boot camp, we'll be starting with the introduction of LLMs, GenAI, understanding word vectors, jumping into prompt engineering, the best practices to be followed around it. Okay. Then we'll cover origin LLM enterprise architecture to a bit more detail, try to understand the pros and cons of certain decisions that you will make while building these applications. And then the last part will be hands-on development with real-time LLM app building. There are prices for top projects that will be coming out. For example, there are Xbox controllers, there are speakers, there is phone camera lens that we'll be giving away. And there's a t-shirt for everyone who builds a project beyond a certain level. Like, so it's not that we can simply copy paste an existing project. That's not the goal of this particular bootcamp. It's for us to enable you to build awesome stuff. So these are just ways for us to do it. Okay. And the giveaways is just as a way for us to we know that once you try to approach more complex things, more complex projects, you may encounter hurdles, and we just want to incentivize from our end for you to put in that effort and not give up so easily. So that's why the prices and all those things. Also, we'll be showcasing, like, if you build a cool application, we are more than happy to showcase on the official blog of Pathway, saying that these are some of the top community projects that came out of this. And it's a cool thing. I mean, as a student, if the maker of a framework is saying that your project is cool, it's a good thing to showcase, right? On your resume. You can use it, certainly. Uh, this is the link for the registration of the bootcamp. You all can scan this to get access to it. Okay. Yo. Okay. Cool. So this is the link. This will take you to an Unstop link. Unstop is the website where the bootcamp is hosted. No, bootcamp curriculum will be hosted on another link, but this is where you can go and register. Unstop is a very popular tool, should not be an issue. For those of you who are already from IT Kharagpur, you would know of Unstop very well. Okay. And yeah, this is the last thing. And yeah, I mean, at last, I would just say a couple of things before I wrap up this particular session and take up the Q&A. One thing is very important. Let's go and quickly, uh, if you now that we have covered everything, right? If you read this particular section in terms of what all this particular tool can do, you will be able to understand and appreciate a bit more, given that we've covered. Okay, this is not about Pathway. This is more about RAG. Pathway is just good for building these things. Okay. And these two QR codes here are for one of them is for the LLM app, which is the RAG framework, and second is for the stream data processing framework. The streaming framework is more cooler one if you are into streaming or data processing or want to build some very cool applications. It's a great enough thing to show. And lastly, yeah, while I am present on behalf of Pathway here, it's actually all these people who have made it possible. So, like, I would definitely want to thank them. And there are more folks actually. There's Bobo. There's Vijay who has led this particular project called as Vision Transformers at Microsoft. He has contributed the Vision Transformers module. Okay, he presented his work at Europe, and then he came and delivered a session. It's given as a recording. There's there is Mike Chambers, who has his own course on Coursera, and deep learning AI has allowed us to use few of resources. And yeah, I mean, cool people have made it happen. So we look forward to seeing you in the bootcamp. And now I'll try to pick up a few questions as we are towards the end of the session. Okay, cool. So first off, this is link that we've added here. I'll move this particular thing here. This, yeah. Hmm. Okay. Cool. So let us try to pick a few questions that are out here. Okay. This is the first blog around Streamlit. Just search for building a real-time LLM app without vector databases. It will give you the same link. Search for Streamlit also. Then Google is that much smart. It can give that. Okay. Then you can search for LLM app space pathway or just LLM app should do. If it's not working, search for LLM app space pathway. In terms of questions, right? So um, there is a way to connect the whole web page to the chatbot. Yes, there is. You can find those connectors very easily. In fact, but frankly enough, from an application building standpoint, okay, this is also called as like I think this is also called like a plugins or agents based approach where the plugin is simply going and visiting a particular page and scanning it and putting that in a format where it can be either you will retrieve information from it or you will put all of that into the prompt. Okay, there are different applications that use different approaches to it, but that is not the most efficient one because that is what Google Gemini does right now, by the way. Okay, I don't know how it is working because with something like Perplexity AI coming in, would have definitely left them a bit perplexed. Okay, but like essentially, if you would search on something like Bing AI search or Google Bard, what it would do is, let's say if I search who won the who scored a hat trick at FIFA World Cup recently, the answer is Kylian Mbappe, a player I tend to like a bit. But if you search that question on the internet, right now, what it will do is it will first search that query on Google. Okay, if you would simply do that on ChatGPT, you'll see that happening. It shows that workflow happening. Okay, so it will search that on Google and then it will simply visit that page, read what is there on the page. If it's within the context window, it's fine. Or is it will pick the starting and the last elements of it and will give you the output. Now, essentially, what is the problem in this approach is that it is not capturing the entire semantic information primarily. Even RAG as a field can improve a lot. It will improve massively with time. Okay. While it is the state of the art technology, it has to improve a lot still. But it is still way better than this approach of visiting the top page that is coming across and then retrieving the information from it. So that is why companies tend to the better approach is that if in certain way you're able to index all of it in a real-time vector index and retrieve from it, then it is more efficient, which is more complex to do with, but with something like Pathway, it is doable. Without a streaming framework, it becomes a bit complex if you have to work with such a massive corpus of updating data. Uh, so you need separate databases for structured and unstructured data. No, we don't need the structures. No, no, this is okay. So this is the question that Matthews asked. You need a separate database for structured and unstructured data. No, that is not. But typically, you think from it from the angle of a company, they would have certain use cases where they would want to work with a structured data itself, which can be for a variety of reasons, for generating a dashboard, for example. Okay, for whatever use case. Okay, and or even for alerts. Interesting thing. I'll show you. For example, let me show you that example. It is, hmm, okay, let me share my screen. I'll show you. That's a very interesting use case. Okay. Um, can you see my Brave browser? Yes, you can. Okay. So let's go to this thing, pathway.com. One second. Okay. And let's go to solutions and let's cover this thing around. Yes. So there is, I mean, I'm just trying to find the hosted pipelines. Should take you to an Excel sheet. Yeah. Yo. Okay. So this is basically a showcase which has become quite popular lately. So what they have done is they have all these things are retrieved with the help of formulas only. They have not copy pasted here. The example we were talking about, right? So what they have done is you simply dump everything in a documents folder, okay, which is basically a set of legal documents here, okay. And then using this particular application, you can simply ask questions and get the information in the form of an array within a Google Sheet. And then you can set up alerts. For example, think at it from this angle. Let's say we have an MOU with folks at IT Kharagpur, okay, and we want to set up an alert. Let's say this MOU is for typically let's say we signed an MOU for 2 years, but in this case, since both of us were excited, we signed it for 3 years. These numbers are hypothetical, don't take it seriously. But still, let's understand this. So now there's one agreement that is expiring. There are all agreements who are expiring every 2 years. And there is one particular agreement that is expiring a year later. Okay. Now, in the case where the deals are very huge, when it's a very high stake thing, such a delay where you simply miss to renew an agreement can cause a lot of problems. Okay. So you might want to set up a simple alert based on certain conditions. Now, for that, you might want to capture it in an Excel sheet or see it in one place. That's one use case. Or other use cases, like for example, in the case of financial data, it is typically in the form of a lot of documents that the companies may be publishing, and then these traders would want to capture that into a particular table to see how it is performing with time or set up certain alerts. And again, you might want to convert that into a structured data. Okay. So in this case, what they've done is first they are retrieving the information here. Then you're asking questions based on this. If you look at it, it is this PWAI answer question, C4A5. Like the question is this one, and it will answer based on this. What type of agreement it is, who is signing that, and everything. Now, if you look at it from a company's angle, they essentially had to do a lot of lawyers had to spend a lot of time trying to do just this. So you are making their lives easier, thereby solving a problem, thereby creating an opportunity for yourself. Okay. Do you just refer it through Python code, or there is a specific method to do that? Okay. How to? I think this is the question of Matthew. How to connect vector database to the LLM model? Now there are these frameworks that make it happen. It's not so complicated. When you visit them, you will find it. I mean, this is the least of the concerns that you'll come across. Typically, the complexity comes around building more advanced RAG applications. For example, if I'm implementing this particular tool for a financial company, then I would want to have a model working which is doing the PII detection first. PII is personally identifiable information. I can't go and ingest all the personal data of Mudit in the particular chatbot. That is not legally compliant. Or if you're a GDPR compliant company, which is a law in Europe around privacy laws, then you will have to have certain laws in place. Or let's take another example that I have seen, for example, companies using it for certain HR documents. Okay. Now I can't go and ask, like, tell me what is the salary of my boss, or how was his appraisal. Okay, now that involves retrieving information from a document, but that is beyond my level, right? I can't go and ask my manager's salary or their appraisal. So you would want to have a model working there as well, which will tell that okay, this is what is allowed, this is what is not allowed. So building more and more advanced RAG applications with more kind of use cases is where your focus typically, where the industry's focus is, where you might have to focus. One application that we saw, a very cool one that came out from the community in India, was where folks at NIT Trichy, they basically built a project where they were listing a lot of information. Like they had this weather's data, they had geolocation data, they had a few other things, and it was basically built as an application for policy makers and administrators in the times of crisis. So it was like, okay, yeah, normal public will not use an LLM when they have a flood coming up, but the administration, they need to give real time updates and very quick suggestions on a real time basis, and they themselves are a bit confused how to do it so quickly. So if you basically combine all these data sources to give a very efficient output, then you can actually make them more efficient, which is how AI is supposed to work today. So those things you can try to build. Actually, that is where you should probably focus upon. Hope that answers it. I don't know if I'm asking the right question. Does RAG understand the database structure, positioning of the contents of the source? For you can do that with the help of meta data. You can do that. In fact, it is also I mean, in a lot of use cases, you would do that because, like, positioning of the contents of the source. Yeah, you can do that. In fact, in RAG, it is recommended because many times when you implement this in a real-time source, right, in a production environment, so there's this concept of hallucination. The word of, interestingly, yes, the word of 2023 year was hallucination. If you don't know that, word of the year by Oxford or someone. Okay. So in that case, what does hallucination? You don't know, right? Basically, I was hosting this podcast with a prof a long time ago, not so long time ago, and he used this term which is slightly like a cuss word, but he was right. It's like LLMs are very good at giving a very educated BS. Okay, so like it will really give you that information as if it's sounding very correct, but it is nothing but true. Okay, so in that particular case, like when an AI hallucinates, it produces false information, right? So in RAG, you can actually address this to a very considerable extent. You can't stop it from hallucinating 100%. But what you can do is, if you're able to show that, you know what, this is the answer and this answer came from this document, then the person who's reading it, they can go and verify it, which is how you're improving the reliability of an LLM. That's a great question, I think. Yeah, it is very much used in the industry. Okay. Um, I'll stop sharing and I'll pick the last question. If there's any other question, I think we're almost out of questions. And yeah, but if you have any questions, let me know. But yeah, I'll pick this one. Up to what level is making our LLM real time feasible by using RAG instead of fine tuning? Also, what will be the source of real time data? Source of real time data can be for that actually the thing we covered, right? The source of real time data can be a ton of things, which can include, again, your databases. That is a source of real time data, right? Let's say in the case of Netflix CEO, let's take that example, right? In that case, it is taking the sales numbers from my database, right, which has these numbers captured, or maybe my CRM, which is something like HubSpot or Salesforce. That can be a source. You can have the internet as a source at certain times. For example, there are projects that people have built where they are simply making it easy for they're basically scraping the GitHub issues and then helping a product customer support team to answer questions basis the things that have been discussed in the GitHub issues page. Okay, that is also a real-time data source. The latency is not so crucial there, but it is a real-time data source. The example of logistics, the one that we took in the case of Transdev, or any other application. Let's not be specific to a company, but let's say Ola. That is like not Ola. Let's take a public transport. Let's say DMR, Delhi Metro Rail Corporation, has this application, and you want to ask questions that tell me, is the metro running on time, or I have to go from this point to this time, this point. How do I go about it? That will work on real-time data. There can be a lot of real-time data sources, and you will find those built-in connectors beforehand. So essentially, connecting them is not the issue. Primarily, the issue will come in terms of ideating. If you're new to development, then the issue will come in terms of using Docker, because typically it is advisable that if you're using open source, use Docker. Otherwise, troubleshooting becomes a bit more troublesome. But yeah, those are the issues again. And up to what level is LLM real time feasible by using RAG instead of fine tuning? Fine tuning is in fact not feasible for real time. Uh, the question is quite the opposite, Raghuveer. Like, um, whenever you are dealing with a dynamic set of data, think about it this way, right? If you have to fine tune every day, you can't end up getting label data set for fine tuning every single day when data is updated hourly basis. Or in the case of, let's say, location and everything, it is updated in real time. That's such a cumbersome thing to do, right? Or another example, very interesting thing, by the way, that you might not be aware is, so for fine tuning also, these tools like OpenAI, AWS, and all these, they have tools for fine tuning, right? So the fine tuning API of OpenAI, the last time I checked, that is roughly 80 times costlier than that of the embeddings generation API. Okay. So there's a massive difference when it comes to cost. And I'm not even talking about feasibility. It is not feasible to get a label data set for such a dynamic data, and that too unstructured data. But parking that aside, even if you have it, like, it's a much more complex and expensive, computationally expensive thing to do. So you would not end up using fine tuning in that case. Okay. So when converting another question, so when converting raw data into vector embeddings, there is no need to store it in a vector database by using it in the code. Depend on the framework. If you're using Pathways LLM app, you don't have to use it. In almost, I'll be more specific. In every framework that I have seen, apart from the LLM app framework of Pathway, all of them, they require a use of vector database. Even in the case of Pathway, you don't require it because it is being stored in the form of vector index within the program memory. Otherwise, you will end up needing it. Yes. Um, that and see, there have been very interesting opinions around this. Like, it's like this, right? I mean, initially vector embeddings was an interesting space to be in, and because recommended systems was the primary use case. Then when they became big, when people started using RAG and all, they became even bigger. A lot of VC money poured into these things. Okay, now with more VC money pouring into these things and these big companies arriving out of it, they have this prerogative of pushing more and more of their tool to the companies, right? So that is why you see vector DBs being used quite proactively. It's not that they're not popular, but it does come with its own set of challenges. And also, secondly, a lot of these existing incumbent databases, like for example, Postgres has this PG vector thing, which is built-in vector management capabilities that these databases who were already existing. They've also built it because they now realize that companies want to manage vectors, and they're willing to spend a bit more money for that. So they will build these features and retain them, or simply upsell them, or whatever that is. Okay. But essentially, from a production environment standpoint, you don't need to use a vector database unless you are reaching a very massive scale. What that scale is depends on the corpus of your data. There are a few numbers that are published out there and a few blogs that I've read. But till a point, I think I don't remember the exact number, but I think there is till a point you have a million vectors or something like that. I don't remember exactly, but yeah. Been speaking for around 1.5 hours now. But yeah, I think that particular blog will give some context around whether you should use it or not, but you don't need it. Typically, if you're building your application for testing or for production, for the initial set, you would not end up using MinterD. Okay, if you're building it at a scale where, let's say, like I don't know how Perfect Slate AI works. I don't think they've published it. But if they're converting the entire, which is very likely the case, where they are generating a real-time vector index at such a scale, then they will have to use a vector DB most likely if the corpus of data is that big. Then in that case, you can still use Pathway, but then you will not use Pathway for just simply vector managing vector indexes or retrieval. You will use it for streaming. That is when Llama index plus Pathway is typically used. Okay. Okay. I think we are towards the end of the session. This was quite an interesting thing for me to interact with you all on today's date. Uh, do register for the bootcamp because that is where we will be able to give you a more holistic guided approach. We can guide you there, and that is pretty much our goal. Okay, and this particular bootcamp you can also find about it on the like you can search for spinning of real-time LLMs on LinkedIn of Kharagpur Data Analytics Group. You can connect with me on Twitter. My user handle is, I'll share that. It's okay. I mean, whoa. I searched for that and I got a very hallucinated response, which is not the case. Okay. Um, but you can simply connect with me there. Okay. It will be good to stay connected, and but nonetheless, we will primarily look forward to seeing you there in the bootcamp itself. It is a much more direct thing, and folks at Pathway are actually quite competent. It's good to uh, okay. It's good to like be in the community, interact with them, and everything. I'm not so active there, but I do check my DMs from time to time. I'm more active on LinkedIn, but Twitter is where I would love to stay connected with you. So I'm sharing this thing. That's my Twitter. That's okay. Oops, this is from the JPS is the Twitter handle. Okay, so just search for it. Okay, I think you will get it. That's it from my end. Thank you so much for joining in. It was a pleasure. And I don't know what is that tweet that I've made a long time ago. Just ignore that. But thank you all for being here. And I wish you a very happy National Science Day and have a great day ahead and a productive weekend. Thank you, everyone. We'll see you in the bootcamp starting next week. Thanks.